Yeah.
So we know that an element is just one single thing on the periodic table. But what if I put two or more elements together? What do we call that?
A bond.
The bond is what's used to put two of them together.
Oh,
A molecule. Good job. A molecule is what we call when we have more than one element put together. What if I ask you, what is a bond made of?
2 electrons.
2 electrons. And what about how many groups are there on the periodic
18.
And what does that tell you?
How many valence electrons?
Good.
Everybody got one?
What is valence electrons?
Everybody got one?
How many bonds? Possible bonds.
How many possible bonds? I'm so proud y'all doing so good. We speeding through this. So what if I ask the molecular formula for water?
H2O.
H2O, good. And it looks like this. 1, 2, 3, 4, 5, 6. What if I ask proper protection equipment or proper protection clothing for a scientist? Lab coat.
Closed-toe shoes.
Closed-toe shoes. Long clothes, pants.
I say sometimes and that. Sometimes.
Gloves.
Pass it back.
And gloves. Good. Yes.
Thank you.
Yep, your glasses or your goggles, good. And your pants, yep, good. And closed-toe shoes, good. Yes. Gloves, yeah, we got them all, y'all. You got a question?
We need a mask for coronavirus.
We don't need a mask for coronavirus, y'all. Do not allow them to trick y'all into that. What about the life cycle of a plant? Blurt it out. What do we start with? Seed. What we got next? Germination. What is germination? What is germination?
The seed starting to sprout.
The seeds are in
The seed starting to sprout, but what do you do? What are the parameters? Yep, you need it to be wet.
moist.
What else? It needs to be dark.
Cut that out.
Air.
And you need oxygen. Nope, you don't need sun for germination.
Warm.
Fertilizer sometimes.
And warm. You don't want it to be cold.
Right.
Good. What is next after germination?
Seed.
You have a seedling, and what's next?
Sprout.
Sprouts. What's after? What happens
Plant.
after? Good. What's next?
Then plant the seed.
Ooh, they need to run more before science class. This is good.
Yeah, that blood circulate through that brain.
Right. Plants for fruits or flowers. Good. Now, a part of this plant. Do not judge my artwork, y'all. Okay, it's not
It's
an
beautiful.
artist. Thank you. So, can somebody tell me the parts of this plant?
The stem.
Yep, you got a stem
The roots.
and roots. You got
Leaves and flowers.
And the flower. Very good.
What about the stem?
I just said that.
Got the stem
I
first.
just said that.
Now, what is the job? What is the root's job?
To collect the water from the
And to hold the
From the soil. Good. It collects water and nutrients from the soil. What's the job of the stem?
transport the water.
Good. The stem collects the water and carries it to the leaves and to the flowers. What is inside of the stem that does that for it?
Vascular tissue.
Very good. Vascular tissues. Very good. Vascular tissues. Y'all making me proud today. What is the job of the leaves?
To
Convert sunlight into nutrients
and taking air.
And take in
Air.
carbon dioxide. Where does the leaf take in the carbon dioxide?
The
The
bottom.
bottom of the leaf. Very good.
So that takes in carbon dioxide, not oxygen?
Carbon dioxide.
Wow, okay.
Because the plants give off oxygen. for us.
Right.
Very good.
Right.
Good. We are speeding through this.
Give yourself a round of applause. Good job,
Yes.
everybody.
My scientists,
Good job. All right, all right, all right.
Now let's talk about mass or molecular weight. So the periodic table gives us the weight of our elements, and two elements or more together gives us a molecule. How do you find the molecular weight?
You take, say, H2O.
Mm-hmm.
I don't remember how much hydrogen is or oxygen, but you would take 2 of the oxygen weights and add that to the weight of the hydrogen.
You
Since
sure?
it's- I mean, 2 hydrogens to oxygen.
And you add it to 1 of oxygen's weight. So that's 2 times 1 because you got 2 hydrogens, and then 1 times 16 because oxygen's weight is 16. You all understand?
Yes.
Following? Good. So 2 plus 16 gives you
18.
So water weighs how much?
18 grams per mole.
Grams per mole. Good. Unit. A unit is something that describes what the number is. So I would weigh 130 pounds, then bless you, pounds would be your unit. So grams per mole, bless you, is the unit of an element, right?
Right.
I don't have my blue bag. I was going to get her some peppermint. Yep, so she can stop sneezing. Okay, what if I ask directionality? Atomic size, or how big an atom is, grows from which direction on the periodic table?
Left to right.
Down to right.
Left and up.
Left and
Up.
down.
You said up.
Left and down. Gets bigger. It'd be easier if you guys had your periodic tables in front of you, so I'm gonna let that one slide. Do you all remember electronegativity?
Yeah.
Say this word.
Electronegativity.
Everybody.
Electronegativity.
Electronegativity. Everybody say it.
Electronegativity.
What about the directionality?
Right and up.
Right and up. No, right and up. Right and up.
Yes.
Up and right.
Up and right. That means it increases, or it gets, the electronegativity grows, it gets bigger. Now I'm going to tell you what electronegativity means. Electronegativity is when a specific element wants more electrons. And so since oxygen is above, I'm having a brain fart, is above phosphorus, which one is more electronegative?
Oxygen.
Oxygen. So that means oxygen wants more electrons. It's going to suck them all up. Make sense?
Yes.
That's what electronegativity means. Good. Good, good, good. We are breezing through this. Is there something that I forgot?
No.
You sure?
I'm sure.
Okay. Check my notes, see what we're on. We went through that so fast. I'm so proud of y'all.
No.
Okay. Now I'm going to describe to you a new term. This term is called polarity. Can everybody say that?
Polarity.
Polarity. Yes. Like magnets. Yes, that's a good example. Polarity describes or explains. This is very distracting. I'm just going to take this. Polarity describes how strong a bond will be. You all remember bonds, right? And what do bonds do? Connects to elements. Polarity will tell you how, bless you, how strong a bond will be. And the way we learn polarity is through electronegativity or the lack thereof. Yes, bless you. Hmm? A letter? Polarity. Nope. Better?
No, I can see it.
That's how you spell. I'm pretty. I know my spelling is bad, but that's how you spell polarity. Yes. Huh? Go for it. So polarity tells you how strong.
What do you need, brother?
Paper towel.
Here. Here.
Devon.
And grow there's more. Okay, so opposites attract, right?
Right.
You all understand that?
Yeah.
So because opposites attract, the more opposite the elements are, the stronger the bond will be. So in water, and I need a periodic table. I left my bag in the car. And I got some in my box. Wonderful. Thank you. So remember our trend or our directionality with electronegativity. We said it increases going, it increases going to the right and it increases going up, right? So is oxygen or hydrogen more electronegative? Oxygen. Hydrogen is all the way on the left side and oxygen is all the way on the right side. The farther that they are from each other on the, what y'all talking? What y'all talking? Very distracting. What's up?
Over here, brother. Over here.
He's trying to give him some hand sanitizer while he's wiping his hand. Throw that away, and then you can get some. Come on, quick. Throw it away in the trash, throw it away in the trash, Then either get you some hand sanitizer or some sanitizer wipes. One second. Okay, throw it away quick, because you're a distraction right now. Quick. What's your question, child? Sure. Oh, that's beautiful. Your notes look wonderful.
Thank you. What? Oh, I forgot to write that up. Can I write that for you? Thank you. The up and down.
Yep, as long as you write the word electronegativity by it. Okay, so eyes on me. The farther your elements are on your periodic table, the stronger the bond will be because the polarity is increasing. Do you understand?
Yes.
So if I make a bond with hydrogen and chlorine, that's hydrochloric acid, that's a very polar bond because hydrogen is all the way over here and chlorine is all the way over here. You understand?
Yes.
Now which one is more electronegative?
Hydrogen.
Which one is more electronegative?
Chlorine.
Chlorine.
Write down what she's putting on the board. I'm gonna check everybody's paper. Write down. Don't just be sitting there doing nothing.
So the way that and let me know if I'm moving too fast. You all can say hold up or slow down or something if I'm moving too fast, okay?
Would you like start over?
You want me to start over? I didn't say that was one of the options. That I'm not doing. I'll give you guys a second. And if you can't see, I think there might be a seat over there for you. When you're done, put your pencils down and look up so I can know to move on. So happy to see that you all are taking notes. That looks wonderful, Theo. Good. Good. Somebody's missing electrons. Remember to draw your electrons. Good. Good. You're missing your electrons.
Draw your electrons.
Oh, I messed up.
Okay, y'all ready?
I have to rewrite the dots.
Okay, the dots are quick, so I'm going to move on. So the way that we show polarity is we draw a line going towards the most electronegative atom, and then we write a plus sign on the end that is least electronegative. Make sense?
Yeah.
That's how we draw or how we show polarity. The more, that's the reason why water and oil, they don't mix. It's because water is polar and oil is not. Very good. Water is polar and oil is not. So things that are polar want to be with things that are polar. Things that are non-polar want to be with things that are non-polar. You understand?
Yes.
Good. I think polarity was quick and easy. Let me see the next one I'm going over. Okay, solubility. Nope, don't erase. Flip the paper over if you need more room. Y'all gotta learn how to write smaller. Okay, so now we're gonna go over solubility. Can you say that? Solubility. Good. Solubility refers to whether or not something will dissolve. Do you all understand what dissolve means?
Yes.
No?
Yes.
Yes. Okay, dissolve means that, let's say you put some sugar in the water and you shake it up and you no longer see the sugar, you only see water. That's because it completely dispersed in the water. It went all the way within the water. Does that make sense?
Like in
Yes.
Kool-Aid.
Yes.
Or like all of the particles or molecules break up. And then they don't become like.
Yeah, that's a good way to look at it. The molecules will break up and then they'll become soaked up in the water, if that makes sense. Okay?
Not really.
Ice and water are kind of the same molecules, so I think it's just temperature that makes that melt into the water.
Doesn't the molecules get closer together when they freeze, and further apart when they gas, and in between when they're liquid?
Yep, and that's the temperature thing. So if you got water looks like, how can I draw this? Let's say we have liquid first. Then we got ice. Nope, I went backwards.
Someone said Kool-Aid. Yeah, it is.
Kool-Aid's a really good example. Kool-Aid is a really good example.
Austin, you're not writing down what's on the board. I guess you just-
The thing is,
I love 3D.
just
Oh, yeah.
So we got solids and we got liquids.
And
gas.
Good, and gas. These are our states of matter, or the things that take up space.
I love that in science.
Good. Okay, I need y'all to not cut me off so I don't forget my train of thought. So ice, let's say, is at like, I don't know what the exact temperature is, but we're gonna say 32 degrees Celsius. Now if we heat it up, y'all remember what's the symbol for heat?
Triangle.
Triangle, good.
Good job. No problem. Good
Now if
job.
we heat up the ice, then those molecules break up and they become liquid, water. So let's say that's 68 degrees Celsius. I could be completely wrong, but that's okay. And if we heat it up even more, then we get our gas, because they are spread apart even more. Yes.
Does the water evaporate?
Yes.
Yep. Yes, water evaporates into our gas. I can't believe you even know what that word means. I'm proud of you. Smart. Okay, so back to solubility. Solubility, you didn't need to write that. That was just me explaining the answer to a question.
No, it's okay.
But it should be broken down.
Good job, Theo.
Write it down if you want to. Good. Y'all write fast. Good. I don't need to see it. So solubility tells you whether or not something will dissolve. And what else do I need to tell you all about solubility? Oh, solubility in terms of polarity means if something is polar, it will be soluble in something that's polar. Or something that's non-polar will be soluble in something that's non-polar. Does that make sense?
Yes.
Great. So now I've
So-
got a quick video.
So what's non-polar?
Non-polar is if it doesn't have like that separation of charge.
Okay.
So the bond isn't as strong
Okay.
as a polar. I have my video up. Now I gotta print it up all over again. I had it up already.
Make sure you put your names on your notes.
Even if we write on the backside,
Oh, yeah.
even if we write on the backside and our names are on the first.
That's fine.
Wow, I have my video so ready for this.
I don't know why it's leaving out. It's, you know, I guess it's on a certain time.
It doesn't.
That's it right there?
Oh man, I like that show. I used to watch it. But yeah, it's still Coach is trying to get up to like at least I know, Coach is trying to get up to like at least 100K. Didn't you say that?
100 or more.
Just keep rewatching the video over and over.
No, like you can't. It doesn't go up if you keep doing it. It's gonna be the same amount. Different you have to watch it. Trust me, I tried doing that. It's gonna be the same amount. got a YouTube too.
You talking?
Okay, cool. Yeah. Like 100 and 200, 100, 200. On one of my videos from 2 years ago, I did 2K.
Welcome to.
You got 2K.
No, I deleted it. It was from 2 years ago.
How many views you got?
Yeah. Because I'm like at 150 something. So it's like 156. 156.
What about the views?
Dang, I got two. Why is it only a minute?
Welcome to the New Business Short on the words polar and non-polar in biology. Consider these bonds within a one molecule. Oxygen is more
No,
electromagnetic.
you don't have to. Okay, you don't have to write this. I just want you to pay attention. So no talking, no questions to the end. Just watch the video. That's all I want you to do. No, we're gonna keep the lights on.
Welcome to the New Business Short on the words polar and non-polar in biology. Consider these bonds within a water molecule. Oxygen is more electronegative than hydrogen. Electronegativity values are based on how much of an atom of an element attracts shared electrons. You can find out how to look up electronegativity values in the trend on the periodic table in our video description. So oxygen is very electronegative here. This unequal sharing of electrons makes each of these bonds a polar bond. Now, just because oxygen is very electronegative doesn't mean its presence would make a bond polar. For example, if you put two oxygens together, that is going to be a non-polar bond, as there will be an equal sharing of electrons. Non-polar bonds tend to have a very small or no electronegativity difference between the atoms involved. Now, whether an entire molecule is polar or non-polar, it would be based on not only the bonds present, but also the impact this has on the molecule's structure and geometry. Check out our video description to learn more.
You all understand polarity? Yeah. Wonderful. Now we're gonna watch one more video that explains polarity within water.
Could somebody explain polarity since you don't understand it so much?
Welcome to the
Not
Business
you.
Short.
Anybody? Explain polarity. Y'all keep saying yes, explain it. Anybody? Explain.
It describes how strong the bond between the two elements of the periodic table are when they make a molecule.
Is that right? Good job, my brother. Good job, Dimitri. Dimitri wants to be a scientist anyway.
I love that. Okay.
Actually, he's a scientist now. He just has to grow into it.
Right, you're a scientist now.
This is Fast Twitch, a new energy drink from
Calm down.
Great.
Calm down, fellas. Calm
Okay,
down.
eyes and ears. 10 years ago.
He wasn't even born.
How come some insects are able to walk on the surface of a pond, but you quickly sink to the bottom when you try to walk on water?
Hurry up, bro. We about to
And why
learn
do
something.
lakes freeze from the top down in winter? In a word, the answer to all of these questions is polarity. Water is a simple molecule made up of one oxygen atom and two hydrogen atoms.
So you guys see how they've got all these little bitty dots in the middle, then there's a circle and another circle?
Yes.
That's what I meant by the outer shell and the inner shell. So on the inside they've got protons and neutrons, and then there's one shell that has 2 electrons, and there's another shell that has another amount of electrons, but its outer shell is what binds to another element. That makes sense?
Yes.
But it is essential to life. In fact, water makes up approximately 60% of the adult human being's body weight. The polarity within those water molecules gives this common substance the properties that make it unique and life-sustaining. Polarity refers to the unequal sharing of electrons within a molecule. For water, the bonding between the oxygen atom and 2 hydrogen atoms within a single water molecule is like a tug of war between a big, strong football player and a cute little toddler. Oxygen is a larger atom with more protons in its nucleus than hydrogen. These positive charges are like a person's physical strength. They are able to attract the negatively charged electrons in the bond, just like a strong individual is able to overpower a weaker individual in a tug of war. So, oxygen is able to attract more than its fair share of electrons. Because hydrogen is smaller and has less strength, or fewer protons, it loses the tug of war and attracts fewer than its fair share of electrons. So So the oxygen in water behaves as though it's negative, and the hydrogens behave as though they're positive. The bonds within a single water molecule are called polar covalent bonds. Covalent means that the electrons are shared. But, as we just learned, polar means that these electrons are not shared equally. In water, the oxygen acts negative, and the hydrogens act positive. Since negative and positive attract, that oxygen is attracted to the hydrogen atom in neighboring water molecules. A special type of bond forms between water molecules known as a hydrogen bond. Hydrogen bonds don't just happen in water either. They can form between a water molecule and different substances that are polar or ionic. Water's ability to stick to itself is called cohesion, while water's ability to stick to other substances is called adhesion. Now, think back to the initial questions. First, why are some insects able to walk on water? Surface tension due to hydrogen bonding creates a thin film on the surface of water that gives enough resistance for super light insects to walk on. You can't walk on it because the hydrogen bonds aren't strong enough to hold you up. Why does ice float on top of liquid water? For most other substances, the solid state is more dense than the liquid state, but that is not the case for water. Hydrogen bonds keep water molecules farther apart in frozen water than in liquid water. The farther apart the molecules are, the less dense that solid is. So ice is about 9% less dense than water, which means it floats on the top. That's why lakes freeze from the top down and aquatic life is able to survive through a cold winter every year. It is the polarity of the water molecule and the resulting hydrogen bonding that account for water's unique properties. So, the reason that water is so special, from inside your cells to the world's oceans, is simply because it is a polar molecule.
Is there any questions? No. Does the video make sense? Yes. Do you want to watch it again? No. Yes.
He said, why don't you want to watch it again?
I heard enough yeses.
Why don't you want to watch it again?
It did look like a belly button. 1 second, but that's how a cell looks. So when they take our blood, when they take our blood and they extract it and they put it into like a solute, which is something that we call like a liquid that we put stuff in, then we can like look at them in a microscope, and that's what they look like to us. So that's why they drew it like that. What's your question, Arson?
That one was specifically a red blood cell, right?
That was a red blood cell. Very good. What do red blood cells do?
They're the ones that carry oxygen through and remove wasteful. I forget the term, but it removes waste from your body, basically.
Good. They basically move a lot of oxygen. What's your question? He got his bathroom.
He all right.
One more time.
Take more notes.
Take more notes. Got the opportunity.
How come some insects are able to walk on the surface of a pond, but you quickly sink to the bottom when you try to walk on water? And why do lakes freeze from the top down in winter? In a word, the answer to all of these questions is polarity. Water is a simple molecule made up of one oxygen atom and two hydrogen atoms, but it is essential to life. In fact, water makes up approximately 60% of the adult human being's body weight. The polarity within those water molecules gives this common substance the properties that make it unique and life-sustaining. Polarity refers to the unequal sharing of electrons within a molecule. For water, the bonding between the oxygen atom and two hydrogen atoms within a single water molecule is like a tug of war between a big, strong football player and a cute little toddler. Oxygen is a larger atom with more protons in its nucleus than hydrogen. These positive charges are like a person's physical strength. They are able to attract the negatively charged electrons in the bond, just like a strong individual is able to overpower a weaker individual in a tug of war. So, oxygen is able to attract more than its fair share of electrons. Because hydrogen is smaller and has less strength, or fewer protons, it loses the tug of war and attracts fewer than its fair share of electrons. So the oxygen in water behaves as though it's negative, and the hydrogens behave as though they're positive. The bonds within a single water molecule are called polar covalent bonds. Covalent means that the electrons are shared. But, as we just learned, polar means that these electrons are not shared equally. In water, the oxygen acts negative, and the hydrogens act positive. Since negative and positive attract, that oxygen is attracted to the hydrogen atom in neighboring water molecules. A special type of bond forms between water molecules known as a hydrogen bond. Hydrogen bonds don't just happen in water either. They can form between a water molecule and different substances that are polar or ionic. Water's ability to stick to itself is called cohesion, while water's ability to stick to other substances is called adhesion.
Adhesion.
Now, think back to the initial questions. First, why are some insects able to walk on water? Surface tension due to hydrogen bonding creates a thin film on the surface of water that gives enough resistance for super light insects to walk on. You can't walk on it because the hydrogen bonds aren't strong enough to hold you up. Why does ice float on top of liquid water? For most other substances, the solid state is more dense than the liquid state, but that is not the case for water. Hydrogen bonds keep water molecules farther apart in frozen water than in liquid water. The farther apart the molecules are, the less dense that solid is. So ice is about 90% less dense than water, which means it floats on the top. That's why lakes freeze from the top down and aquatic life is able to survive through a cold winter every year. It is the polarity of the water molecule and the resulting hydrogen bonding that account for water's unique properties. So, the reason that water is so special, from inside your cells to the world's oceans, is simply because it is a polar molecule.
Still no questions?
No.
Good. Good. Yes?
It's a reverse.
I got a question. I got a question I want to ask. Who had a question? I'm sorry. Go ahead.
What's your question? Take somebody. What's your name? Kalani, do you mind going to the bathroom?
We'll be all right. We're about to finish in about 5 minutes. We'll be all right.
That's being that fast.
You gotta use the bathroom. For real, for real. Can you go to the bathroom, please?
So what is it when the molecule is attracted to something? It's called what? When it's attracted to something, not arson. What is it when a molecule is attracted to something?
They're in love.
Adhesion. Adhesion. Good job. What is it when it's attracted to other molecules? Somebody other than arson, not to be discriminatory, but come on, I need some other thinkers in here. You heard what I said? I'm sitting right next to you. What is it when a molecule is attracted to another molecule? Don't raise your hand if you don't know. You got adhesion and cohesion. Come on, we need to be paying attention. When she say, do y'all understand all this? Yes. Don't just say it, just be saying yes. You got to understand what's going on here. It's very, very important. You said no?
What didn't you understand? Oh. No more questions? Can I move on? What's your question? You got a comment? What's your comment?
That adhesion is not supposed to do not attract.
Right, molecule to molecule is cohesion, and molecule or water to something is called adhesion. Good.
Good
I
job.
didn't teach y'all that. That like wasn't a part of my lesson, but it was in the video, so that's good. What's your question, Theo? Oh, what's your statement? Oh, what's your statement, Chandler? Oh, okay. What's your question, TJ? Yeah, spiders.
Hey, that's okay. You ain't got to go back far.
I hate spiders, but for some reason you cannot drown them, and I've tried. I've really tried. That's,
Well,
I love curiosity.
Donnie has a question.
What's your question, Donnie?
Some spiders can walk on water. Not like, well, some spiders can, like water spiders,
Can I ask?
Right, can I explain why? Yes. Because she explained it in the video too, because the hydrogen bonds, which is a type of bond which we'll go over later in a different lesson, but hydrogen bonds are so strong that because spiders are so tiny and so light, they're not able to break through those hydrogen bonds. So that's why they're able to walk on water. What's your question, Chandler?
What about worms?
I don't know.
What about
I feel like
Can I ask a question?
What's your question?
How does, like, when you learning how to swim and everything, how does your body float on top of the water? What does the body do? Arson has the answer.
Wait, let me think.
Okay. Because I mean, even snakes, some snakes can swim across the water.
Like I know it's about surface tension, but
She was on the swim
okay,
team.
go for it, Arson.
Basically, the oxygen in your lungs is keeping you afloat because it's stored in you. It's like when you breathe out, that's how you sink. When you breathe in, it keeps you afloat.
Wow.
It doesn't fully keep you afloat, but it keeps you afloat just enough.
That's cool.
That's a good survival. Good job. That's a good survival. That's a good survival notation also.
What you got there?
So like when Arthur said that, does he mean like when you lay back on the water you have to breathe real quick?
No, she means you gotta hold your breath. Keep the oxygen in your body. Any other questions, comments, fun facts? What you got, Chandler?
How do worms sleep?
Because the surface tension of the hydrogen bonds is not strong enough to hold the weight of a worm. So that is why they
Worms
say
aren't that even heavy.
they may not be heavy to you, but to a hydrogen bond in water, they're pretty heavy.
What does water evaporate to?
A gas.
But as a gas, it just lingers. Does it go up or down?
Sometimes it can be in bubbles, which is like the in-between, or sometimes it'll just evaporate into the air.
Okay.
Yes. Sure. Take
No, he can go to the bathroom by himself. He ain't gonna take nobody. He just go this way. That's somebody else is not learning.
you let me run my class at my time.
All right.
You can go this way. You can go this way. Okay, questions, comments, concerns, fun facts, we're good? Let's move on. Wonderful. So another thing that she talked about in the video is density. That's another thing that I wanted to teach you guys. Density, or how dense something is, depends on the mass or its weight, and it also depends on the volume or how much space that it will take up. Does that make sense?
Yeah.
So mass tells you what? Weight, how much it weighs. And volume tells you what? How much space it can take up. And so she mentioned ice floating on top of water. And the reason why ice floats on top of water is because in a solid, the water molecules are really, really tight together. So I told you that water looks like this, right? In actuality, water looks like this. Because these hydrogen bonds, we look at water by itself like this for 18 grams per mole, how much it weighs. But in actuality, a big thing of water has way more than just one molecule of water. So all of this is a whole bunch of water molecules together. So as a solid, these are really tightly held together. So they don't have much space or much volume. So they're more dense. Because it's more dense than water in its liquid form, it floats on top of the water. Does that make sense?
Yes.
Are there any questions? Wake up!
Wait,
No question?
you said it was more dense than water, so it floats. Don't you think it was
Water
less
is more dense than ice, so it floats. Thank you. Yes, thank you. Yes, please. Why is water clear? Because so you guys know Roy G. Biv, The Color of the Rainbow, right?
Yes.
Water is something, or the color of water is something that we scientists call translucent. And it is clear because, so we get color from like light. And when light bounces off of the, wait a minute, hold your question. When light bounces off of different things, that's what gives it its color. But I feel like water, that's a really good question.
You gonna answer the question, my brother?
I don't think I know a deeper way to explain why water is clear.
Go ahead.
Not fully, but I'm just
Go for it, Arson.
hypothesis is that it either bounces off all the colors or none of them.
What'd you say? Hypotheses, huh?
When
I like that.
something
I'm not sure if
absorbs-
water actually has color though.
We gotta answer back there.
Yes.
My guess would be that it's not, well, besides that it's translucent, it's not contaminated by any other molecules like that, purified. When you go to the lake, you have different molecules in it, so you get different colors as purified water.
That's a good hypothesis. I'm really not sure. However, that's just what we know so far is that water is translucent. It doesn't have a color. But that was I love the curiosity. What's your question? Why isn't water blue? I don't know.
Come on, you're on camera now.
Yeah, I think in movies they just maybe they want you to see it, or maybe the color and the paint of the bottom of the pool is blue. Yeah, that's from like the sun and probably different stuff that's in the water, like that back there. Your question, Shane, or comment?
Any water.
Oh, I got a lot of questions.
Why is ocean water made of salt?
Why is ocean water made of salt? Well, inside of the earth, right, way down deep, we have like salt. And I guess
How does salt get inside of
that, I don't know. That may be a question that you pray at night for God. But we just know that we have salt. And it came from the very, very bottom, underneath the ground.
What'd you say?
Like all of the dirt and stuff moves around, and then you have like water. The water takes up the salt in it. That's why we have salt water.
Dimitri said, he said erosion.
Yeah, I
Yep,
forget
that's
the-
what happens from the salt and then bottom of the ground. Your question.
When he was talking about water, I was wondering, why do crocodiles live in swamps instead of water?
I think that would be a question for like a veterinarian or something, but I'm like more a chemist, so I have no idea. Arson, you got the answer for that?
Because they prefer fresh water over salt water. Salt water is harmless.
Well, there you go. They prefer fresh water over
But
salt
they do have saltwater crocodiles too.
Exactly.
Your question, Matt?
Going over some work with my kids last night, and I was explaining that it's kind of the difference between mass and weight. You can weigh a different weight somewhere else, but with mass, it's constant.
Yep, that's good. So mass gives you how much something weighs if we're not considering gravity. So gravity is the pull of the earth. It's what pulls it down. Wake up! Wake up!
Austin.
Wake up! How you gonna sit in the front and fall asleep? I just look right at you. And then weight is how much something weighs when we include gravity. So that's why we talk about ourselves and we say weight. But when we look at just an element by itself, we talk about mass. Because most of the times they extract it, they put it inside of this machine, and then it completely gets rid of gravity. So that's perfect. Awesome.
All right.
Any other questions, comments, concerns about that? No. No, we're good. Austin, stand up. Stand up. Right there.
Dimitri has a question.
Right there.
Dimitri.
Everybody else can see.
Dimitri.
Stand up. You can wake up a little bit. What's your question, Dimitri?
When you were talking about why water is clear, the way you see colors, because white light contains all the colors in a rainbow, and the chemicals in an item reflect, like they absorb every color but the color it wants to reflect.
Yeah.
So when something is white, it reflects everything. When something is black, it absorbs everything.
Yeah.
So my only guess for why water would be clear is the light just passes through it completely and it doesn't absorb or reflect anything.
Wow, you know that is exactly why water is clear. I feel like you got $5. You got $5.
For what?
So I feel like you need some money for that. Because I could not think that. Like, Arson had us on the right path with, like, you know, if light passes through all of the colors, but water don't have not hitting nothing, that's why water is transparent.
I think everybody, all the scientists came together for that. What you think? What you think, Dimitri?
You think about taking all the credit.
What?
Can we move on? Yes?
Yeah.
Okay, great.
That's it.
No, I'm almost done.
We ran out of time.
Well, I mean, y'all took up all my time. What do I
Okay.
do?
All right.
Yes. Can I just go through one more thing?
Go ahead.
Okay, so I want to show you guys the separation of polar and non-polar things. Now, soap is something that has shared polarity. So on one end of soap is polar, and on the other end is non-polar. And so since water is polar, and the things like dirt that you're trying to get rid of are non-polar, it attracts the dirt on the non-polar side, and then water, the polar end, washes it away. And that's how soap is. So now we're going to go through, and I'm going to try to show you guys some difference in polarity. It's in this cool, clear container. So it's got water, and water is polar or non-polar? Polar. Polar. Good. What about vinegar? Non-polar. Good. Wait, are you sure? Did you say non-polar? Yeah. Let's see. Is vinegar non-polar or polar?
Polar.
Let's test it and see. So I poured some vinegar in here. And polar molecules will connect to polar molecules, whether you shake it up, mix it up, stir it up. And non-polar molecules will connect to non-polar molecules, whether you shake it up, mix it up, stir it up. So I shake it up, mix it up, and I stir it up. Then we'll wait for it to calm down and stop swirling. Do you see a separation anywhere?
No.
So is vinegar non-polar or polar?
Polar.
Good. So we got vinegar for polar. So water is non-polar or polar?
Polar.
Good. And if I take some alcohol, you think it's non-polar or polar?
Polar.
Let's see.
Polar.
I love this color. Oh, you smell it. Sorry. Vinegar is pretty stinky, but it's amazing. It's wonderful. I love vinegar. I mean, you can use it for cleaning. I just swirl it. So I swirl it around, mix it up, swirl it around. Do you see any separation?
Yes, I do. It's not like that bright green like it is in there.
Do you see any separation?
I don't see any separation.
So is alcohol polar or non-polar?
Polar.
Good. Alcohol is oxygen and hydrogen. Oxygen is on the right side of the periodic table, and hydrogen is on the left side of the periodic table. So that means it has a strong polar bond. You guys remember that from the beginning of the lesson? Yeah. Water, polar, non-polar?
Polar.
Good.
Non-polar.
Now, is oil polar, non-polar?
Non-polar. Ooh, bipolar.
Who said bipolar? Soap is bipolar. Soap has non-polar properties and polar properties. So you can actually say that soap is bipolar. That's pretty funny. So I take it's already got some separation, but I'm still going to mix it up, swirl it up, mix it up, swirl it up.
Not believe that. That's not important.
Do you see separation?
Yes.
That means that water is polar and oil is
Non-polar.
Good. Now I'm going to take some soap. Bless you.
Hey, you're not going to dump it out?
Nope. This used to be like the most fun for me when I was at home. I don't know if my dad noticed, but me and Nene, we used to call it ingredients. We used to take all of the stuff in the house. Sorry, parents, in advance for the stuff that they do at home. But we used to take all of the stuff in the house, like lotion and soap and all that, and like mix it together and see what it made and stuff.
And by the way, I did notice. But look at the results.
Yep, that's my dad. So I'm gonna mix up the soap. I'm gonna mix up the oil. I'm gonna mix up the water.
I don't see it.
I mean, I haven't
See
started
what?
to stop mixing yet.
Because y'all can read it.
What?
He don't think.
I see no.
He doesn't. No, he didn't.
Do you see separation?
No.
Yes. How many layers of separation? Three.
Because it's bipolar.
Let's say it has shared polarity. I thought bipolar was cute and funny, but let's say shared polarity.
Shared
Do
polarity.
you understand why there are 3 separate layers? You want me to explain?
Yes.
Water is the most dense, so it's at the bottom. Oil is least dense, so it's at the top. But because soap has a polar end and a non-polar end, it's one end connected to the water and one end connected to the oil. So you have 3 separate layers. Make sense?
Yes.
So soap is polar or non-polar?
Shared polar.
Good. And that is my lesson for today. So proud.
Everybody give it up. Great work, everybody.